Good evening. This is Miss Lovett here to give some helpful tips for your homework tonight. It's your Monday night homework for this week. So tap in, guys. Lock in. Make sure you catch it. Okay? So, first things first. This week, your child is learning metric conversions, which is really similar to what we have been learning for the last 2 weeks because the power of 10 is still relevant. We are still moving the decimal place. We still are changing out values. But what has changed just a tiny bit is that we now have a mnemonic that we have learned. And it is King Henry died drinking chocolate milk. Okay. And if you really want to be entertained, feel free to ask your kids to sing the song that goes with this. Okay, so we did learn a song in class. I will not be singing it here for you. I will leave that entertainment between you and your child. Okay, so what we learned is that this mnemonic King, the K stands for kilo, H stands for hecto, D stands for deca, this D stands for deci, C stands for centi, M stands for milli. Okay, or the milk stands for milli. And so I recommend it to your kids. Please don't get confused. Deca is A, deci is I, AI, technology, AI. The A comes before the I. Okay, so just remember it that way. When you write it out, it should say AI. Okay? And so what we have learned is that we will be shifting. As a number becomes smaller, we're actually shifting to the left, okay? So we are shifting to the left, multiplying by 10, okay? And so what that means for us is, what you've probably heard of is like kilometers, centimeters, millimeters, milligrams, kilograms. We don't really use hecto, deca, and deci, but centi and milli and kilo are really the primary ones that we use. And so the way that this switches around just a little bit is that at our base, we oftentimes say that it takes 1,000 of our base to create 1 kilo of anything. So 1 kilometer, 1 kiloliter, and 1 kilogram, right? It would take 1,000 of these to make one of these. So that means by default, it would take 100 to make a hectogram and 10 of the base to make a decagram. This seems to be a lot easier for kids to understand than to try to associate it to the powers of 10, but they should still be able to see that relationship. In the same way, 1/10 of my base is a deci, 1/100th of my base is a centi, and 1,000th of my base is a milli. So it takes 1,000 milligrams to make one of my base. It takes 100 centigrams or centimeters or centiliters to make one of my base. It takes 10 of my deci to make my base, okay? Your kids worked with meter sticks today. So we were just working on length, measuring length, and distance today. But we're also going to work with liters a little bit later this week. Not too much with grams, but yes, we looked at an actual meter stick. The kids found how many centimeters, how many millimeters, and they should be able to at least make it through these first 5 problems because this is all we talked about today in class. Okay, so I'm just going to go over the first 3 problems for you guys just to help with your homework at home. I'm sorry it's so late. I apologize that it's so late. And let's see here. So convert 34 liters to milliliters. So the first thing that I would do is have your kid draw out this chart for you. They have it in their notebooks. This chart should be in their math notebooks. They copied this chart down, or one similar to it, not this exact one, but they copied something similar down to this today. So the first thing that I would do is I would find, let's see, liters and milliliters. This should actually be an L right here. I didn't see that that was a mistake on here, but this right here should be liters. This should be an L. Let me make sure the rest of these are the same. Yes. Okay. So this right here should be an L. We should not be converting fluid volume into a distance. So this should be milliliters. And I'm going to actually change that on here. And I'll make sure that I tell your kids tomorrow as well. Okay, so this right here should actually be, let's just, you know what, I got one better for you. Let's change this to white really quick and just and I'm just gonna change this to milliliters. Okay. All right, so let's work through this really quickly, okay? So we got 34 liters, 2 milliliters. So the base in this instance is meter, which is right here. And we are converting to milliliters. So we are actually increasing the number because it takes more milliliters to create 1 liter, okay? So how many milliliters does it take? It takes 10 times 10 times 10, which we should know by now that is 10 to the third power. So we come here and we take our 34 milliliters. I'm sorry, our 34 liters. So 34 liters times 10 to the third power. Now, this should look familiar. It should look just like last week. So we know that we're multiplying, we're increasing our value, we are shifting to the left or moving our decimal place to the right. Don't try to do both. Just remember one of them. I let them choose in class whichever one they want to remember. So we know that we will be shifting our place value to the left. I'm going to choose shifting place value, not moving the decimal. Okay. And so if we are shifting if we are shifting to the left, we're shifting 3 spaces. And so that means we would be, our ones place would now be shifting 3 places to the left. So that would put it in the thousandth place. Yes. So we would have 3, 4. So the answer would be 3,400 milliliters. Okay. I'll do the next one, shifting the decimal, just so you can see that you really do get the same answer. And you can do this either way. Okay. So the next one, we have grams to kilograms. So 4,000 grams to kilograms. We have 4,000. All right. And so since we are going from grams, which is right here, to kilograms over here, we're actually going to be dividing by 10 in this direction. And ironically enough, 10 times 10 times 10. So we have 4,000 divided by 10 to the third power. Okay. And so if we do 4,000 divided by 10 to the third power, then I will be moving my decimal place. If you want to do decimal, I'll make this in a different color though, so that we don't get confused. So if I want to move my decimal place from right here, instead of shifting my number to the right, I'm going to move my decimal place 1, 2, 3 to the left right here. And that would essentially give us 4.000, but we don't need these zeros at the end. We know that that's just equal to 4. Okay. And for number 3, I have 13 centimeters to millimeters. And so right here, you can see my centimeters to millimeters. And so if I'm going from centi to milli, I'm going to be multiplying by 10. Okay. Multiplying by 10, but just one time. So if I have 13 centimeters times 10 to the 1 power. And I'll just do this one with if I want to shift on this one, I will be shifting to the left 1 time. Yes. So my place value will be moving. So that means that 1 centimeter would be equal to 130 millimeters. If I wanted to move my decimal place times 10, that means that I would be moving my decimal place 1 place from here to the right of my ones, right here, to the right, right? And then I will be filling that gap right here. As you can see, we get the same answer, 130. Okay, so you get the same answer. It's just more so about concept and understanding that either we are shifting our place value to the left if we like to increase, or moving our decimal place to the right. Please do not get confused. Okay. Once again, the Board of Education, Georgia Department of Education, wants you to understand shifting the place value. That is what the questions will say on the Georgia Milestone and also on their end of unit testing, their post test. Okay. All right, guys, if you have any more questions, we can go over these tomorrow in class. But because I have done this here, I don't intend on going over in class unless someone has questions. Okay. Have a great evening, guys. Bye.